Welcome to a new Voltlog. Today we're taking a look at this T12 compatible soldering station, but before we continue with that, let me take a moment to remind you to click the small bell icon next to the subscribe button. That is important if you want to be notified whenever I upload a new video. It's not the first time I'm featuring a T12 compatible station on the channel. I got another one many years ago and it's been serving me well over the years. I will link the review video on screen right now. The one I'm reviewing today was sent for free for the purpose of this review by a seller on AliExpress. There seems to be a number of soldering related products branded Ksger on AliExpress. I'm not even sure I'm pronouncing the name correctly, but I'm gonna leave some links in the description below for you to check them out. The main thing you will notice when receiving one of these stations is the fact that the enclosure is plastic. My other T12 based stations have aluminium or at least metal enclosures. It seems Ksger is making these with a custom plastic enclosure, and although aluminium gives a more premium feel, it is more expensive and possibly heavier and more expensive to ship, thus increasing the cost even more for the end user. I like the fact that this enclosure has these indents on the top, which allow stacking of multiple units vertically and will prevent them from sliding on each other. On the back we have an IEC mains connector with fuse socket, so our Chinese friends recognize the importance of a fuse in a soldering iron, unlike a well-known manufacturer which doesn't think one is needed. And next to that we also have the on-off switch. They have several different handle options you can choose from, and the price will vary depending on which one you choose. I asked the seller to recommend me which one is the best, and he recommended this aluminium handle with a carbon fiber insert because he said this is smooth and light and nice to work with. And I must say it looks very nice with this polished aluminium handle. And this, I'm not sure if it's real carbon fiber or not, but it's not a sticker either, so it could really be a carbon fiber tube insert on this portion of the handle. It looks really nice. If you prefer something heavier, you should try the polished steel handle. The cable attached to the handle is really nice. It's a soft silicone cable, and we'll put it to a test with the soldering iron later to see if it melts, but so far it feels pretty nice. It feels like silicone cable, and I think it's going to survive just fine the soldering iron test. They've also included 3 different T12 tips, which are also branded Ksger. If you remember, I did a video where I compared one of these Ksger branded tips with an original Hakko tip, and the results were pretty close. I was unable to prove that one is better than the other. I will link that video on screen right now for those who are interested in the subject. Before turning this on to see how it performs, let's open the enclosure because I'm sure you are curious to see what's inside just as I am. It was a bit tricky to take it apart because it had this sticker on the front panel which was masking the screws, but it was pretty obvious, so I managed to take it apart without breaking anything. So now let's take a closer look at what we have in here. It's the typical construction for these soldering stations. We have a power supply board and the controller logic board. They have used connectors for both the front panel controller board and for the back panel power input, which is really nice and modular. It must be very easy to assemble one of these on their production line. And on the IEC mains input socket we have some heat shrink on the connections, and if we take a closer look at these wires, these are not your typical cheap PVC wires. I wouldn't say they're silicone either, but they kind of have this fibery aspect that makes me think these are somehow fire retardant. I'm not sure, but maybe you can identify this type of wire and let me know in the comments below. It certainly feels good and it feels like good quality wire. Next, here is the power supply board, a really nice PCB, not much flux residue left from the assembly. The soldering looks fine and it looks like it's a nice power supply with all that is required for safety and for filtering. For example, here is the power input. We have a small fuse which is not user replaceable, unfortunately. Next, we have an X2 rated cap for filtering, a common mode choke. Next comes the bridge rectifier and an NTC resistor. We then have a big filtering cap. It's 400 volts, 68 microfarads. Let's see what the brand of this cap is. Well, there is a logo in there, but it's not something I am easily recognizing. But anyway, we next have an Y-rated capacitor, which is probably connected across the transformer, also for filtering purposes. On the input, we have our main switching device. I believe this is some kind of MOSFET. And on the output, I think this is a rectifying diode. Both of the active devices are placed on these nice thick heatsinks. And look, we even have a small logo. This is probably the designer of this power supply. And we have a version number here. This is Soldering Power version 2.04. And I wonder how many versions of these they designed until they got to version 2.04. But anyway, on the back, here is the clearance between the primary and the secondary. Here we have the optocoupler for feedback from the secondary, and there is really a wide opening, nice clearance. This line, if you're wondering, this is the earth connection, which comes right from the IEC input, and it goes right until the output. I believe one of the output capacitors or the negative output connection is somehow connected to the earth connection through a capacitor. If you'd like to see more close-up pictures of this board, check out the link to the blog article, which I will leave in the description below. I've measured the output of this power supply and it's 25 volts. I'm not sure of the current rating of this power supply, but judging based on the track widths and how the transformer looks, what kind of wire they've used in this transformer, I would say that this power supply should be capable of 4 amps. Next, taking a look at the controller board, once again we see the same type of wire being used to bring the 25 volts up to this controller board, which probably contains a MOSFET around here to switch the power to the heating element up to the handle. I'm surprised to see they have this backup battery in here. I'm not really sure of the purpose of the backup battery. Like, couldn't they store data in the EEPROM? They're using an STM32 microcontroller in here, but they are also using an external EEPROM chip. So I'm not sure why they chose to have an external EEPROM, and they also need a backup battery. I'm not sure what the logic is there, but I'm sure one of my viewers will let me know in the comments below. There are a few parts missing here. There's Q3, Q4 and some diodes missing, so maybe they have another version of this controller with more features, or I don't know, maybe they decided that they don't need those parts. On the back of the controller board there's only a small crystal and another module containing the OLED display. So now I have the station back together and I would like to present you the user interface and the menu options that we have on this station. This is the basic user interface. Top left we have the set temperature, this is the actual temperature, this is the currently selected tip, because you can store and configure various tips for this station. Up here we have the current used power in percentage. this is the current time, and this is the cold junction temperature. Now, rotating the knob will cycle through various operating modes of the station. For example, rotating to the right will put the station into boost mode, and I will show you later you can configure the boost temperature and the amount of time the station will stay in boost mode. This is really useful if you're trying to solder or desolder a thicker connection. You just boost for 1 minute, you're done with that soldering joint, and then you're back to the normal soldering temperature. Or you can just rotate to the left and it will go back to the normal set temperature. If you rotate to the left even further, you'll put the station into standby mode, and if you rotate it once again to the left, you'll go into sleep mode. There are also automatical timers that will put the station through the standby or sleep mode, but this is just so you can control it manually. If you want to wake the station from the sleep mode, you just press the button, and the station will beep when it reaches the set temperature. Now let's also take a look through the menu system. So long press on the switch to enter the menu. This is where you set the standby temperature and the amount of time the station will wait until going into standby. You also have the wake up mode. I just left it on auto. I find it wakes up really nice when it's left in auto. Same as before, the settings for the sleep time setup. This is a delay until the station will automatically go into sleep when no motion is detected. These are the boost settings, so it will boost the temperature with 50 degrees for 1 minute. This is for cold and compensation. We have an NTC installed, and we can compensate for its temperature if it's not measuring accurately. This is the menu option that allows you to configure and store various tips for the soldering iron station. You can calibrate for temperature and then store those settings with names in here, and when you switch between tips you will always get the accurate temperature for that particular tip which was calibrated. This is where you adjust the steps per each detent on the rotary encoder. You can set a password for your soldering station. I find that option amusing. It's like, who are you trying to prevent from using your soldering station, and why would you want to do that? But anyway, there's also a screensaver which I have disabled. You can turn on or off the buzzer. There is a voltage display which you can turn on or off, but when using the internal power supply, I don't see the point of keeping that on screen. It might be useful for those using an external power supply, because you might want to monitor if the voltage is sagging too much. You also have a low voltage protection function. Once again, useful for those using an external power supply. You can set like a threshold, and if the voltage goes below that voltage, it means it's sagging your power supply, so it will turn off the MOSFETs to allow the power supply to recover and maybe protect it this way. Here you can select the power on mode. You can have the station running when you turn it on. You can have it go into sleep or standby mode, but I like my station to be running when I turn it on. You have a desoldering option. I'm not sure how this helps you. Maybe there's an option to have like a more advanced version of this station with some desoldering pump. I'm not sure of that. Here you can set the pump time, and once again I think this is related to having another version of this station which also features a pump. You can set the language of the menu, the date and time, the real-time clock, because this has a 32 kilohertz crystal in there, and it's keeping a real-time clock, I believe, using the option available in the STM32 microcontroller. This is system info. Here I have hardware version 2.1S and software version 2.1. And there is an initialization menu, which I'm not sure what it does, but I don't want it to reset all of the settings that I've done, so I'm not going to try that menu yet. As you saw, a pretty comprehensive menu system with lots of options which allow you to configure this station to work exactly like you want it to. When the station goes into standby, or it prepares to go into standby, it will start beeping in a sequence until it really goes into standby, and that's kind of annoying, I think, but after all, you can disable the buzzer completely from the menu system. Even though I like this aluminium / carbon fiber handle they sent me, it's thin, the working distance is short, so I will really enjoy working with this. The tip is easy to remove, there is no screw in here to hold the tip, so you can just pull on the tip and remove it from the handle with ease. However, there are a couple of disadvantages to this type of handle, and I would like you to be aware of them if you choose this type of handle. Well, first, because it's built mostly out of aluminium and other highly thermally conductive materials, the handle will become slightly warm as you work with the soldering iron. This is not something you will notice on the more classical plastic handle, which doesn't feel warm even after an hour or so of usage. With this one, even after 10 minutes of the soldering iron being on, I can feel the handle being warm, and if the temperature in your lab is high enough, it is a possibility that you might start sweating your hands on this handle, which might make it slippery. So you need to be aware of that when you choose this type of handle. Also, another disadvantage is that with a classical soldering iron stand, it just goes through the stand because it's so thin. So yeah, you can place it in here and it will kind of stay in there, but that will probably scratch this shiny handle. So I'm not sure if Ksger is selling any special type of tool stand for this handle, but I'll check on AliExpress and let you know. On the plus side, the sensor they've placed in the handle is super sensitive, and I really like that. It detects immediately as I pick up the handle and it starts hitting, so that's a really good thing. So I was just preparing to calibrate one of these tips. This is a knife tip that they've sent me, and I was just about to try the calibration option for this tip, but look at this, the temperature is almost bang on, like right from the factory with no calibration at all. So this is really nice. It really shows that their firmware is designed to work with their soldering iron tips. These are T12 compatible tips, but it's likely that if you order a different tip and install it here, you might have to run through the calibration function to get the accurate temperature. I'm sure a lot of my viewers would like to see how fast this station will reach 300 degrees Celsius starting from ambient temperature. So right now the tip is at about 26 degrees Celsius, which is really close to the ambient temperature. Let's put it on the thermometer and see how fast we can reach the set temperature of 300 degrees Celsius. So it looks like this new station did it in just about 16 seconds up to 300 degrees Celsius, which is not bad at all, especially considering that while in standby you will be at 200 degrees Celsius, for example, and it's much faster to go up to 300 degrees Celsius. What I tested was from a cold start at ambient temperature, and the result was really good. Out of the 3 T12 stations that I have, this is now my favorite and will be the one that I use daily. I'm not sure if the performance is higher or similar to the other STM32 station I have. I'll probably do a separate video to compare them, but it's just the user interface on this one, the menu options, the really nice handle that makes me want to use this instead of the others. Yes, it has a few disadvantages regarding this handle. It does get slightly warm because it's metallic, and it doesn't really fit that well with one of these regular soldering iron stands, but I can go past those disadvantages for how nice this station is. If you're looking for a T12 station, this is definitely the one to get. I'll put some links in the description below. You can get this station completely assembled like I got it, or in a kit form if you'd like to assemble it yourself, but some soldering will be required and you will need a secondary soldering iron to do the job. That was all for today. I hope you enjoyed watching this review video. Let me know what you think in the comments below, and I'll see you next week with a new video.